Sizing the electrical service for a strip mall involves several important considerations. While your approach of summing the panel capacities and adjusting for the landlord panel is generally correct, there are additional factors that can affect the final service size. Commercial buildings typically exhibit a low demand factor compared to residential buildings due to the diversity in usage patterns. Therefore, applying a demand factor to the calculated load can potentially reduce the overall service size required. Determine if any applicable demand factors or diversity factors are relevant to this particular type of occupancy. Given that the specific occupants of the strip mall units are currently unknown, it would be prudent to provide additional capacity to accommodate potential growth of future tenant needs. Consider slightly increasing the service size beyond the initial calculated value to allow for future expansion without requiring major upgrades. It is essential to thoroughly review the National Electrical Code, specifically Article 225, for specific requirements related to sizing services for multiple occupancy buildings. These requirements may provide additional guidance and constraints that must be taken into account. Consulting with the local authority having jurisdiction is always a good practice. This ensures that your calculations and assumptions are in full compliance with all applicable local codes and regulations. The local authority can provide valuable insights and clarifications regarding specific requirements in your area. You mentioned that the power is 120/240 volt single phase. It is important to verify that this voltage level is indeed suitable for the intended use of the units. In some commercial applications, a higher voltage, such as 480 volts, may be more appropriate and efficient. Ensure that the overcurrent protection devices, such as circuit breakers or fuses, within the 200 amps panels are properly sized and coordinated. This coordination is crucial to prevent overloads and potential damage to equipment. A selective coordination study may be necessary to ensure that the protective devices operate in the correct sequence. Carefully consider the distribution of loads across the various units within the strip mall, as well as the potential for uneven loading. An unbalanced load can affect the sizing of the service and the overall configuration of the electrical system. Aim for a balanced load distribution to optimize efficiency and minimize voltage drop. To gather more accurate sizing information, it is recommended to conduct a load study to obtain actual data on the power requirements of the units. This can involve monitoring the power consumption of similar businesses or using load estimation techniques based on anticipated usage patterns. Working with a qualified electrical engineer is highly recommended. An experienced engineer can assist in designing and specifying the electrical system for the strip mall, taking into account all of the factors discussed above and ensuring compliance with all applicable codes and regulations. Firstly, to determine the appropriate demand factors for the strip mall, research historical data from similar commercial buildings in the area. This data can provide insights into the actual power consumption patterns of different types of businesses. Secondly, consider the potential for future installation of energy-efficient equipment by tenants. Energy-efficient appliances, lighting, and HVAC systems can significantly reduce the overall load on the electrical service. Thirdly, the National Electrical Code provides tables and guidelines for calculating demand factors based on the type of occupancy and the number of dwelling units. Consult these resources to determine the appropriate demand factors for the strip mall. Fourthly, if there are any shared facilities within the strip mall, such as common lighting, HVAC systems, or elevators, include the load of these facilities in the overall load calculation. Fifthly, consider the potential for electric vehicle charging stations to be installed in the future. If there is a possibility of electric vehicle charging, provide adequate capacity in the electrical service to accommodate these loads. Sixthly, ensure that the grounding and bonding system for the electrical service is properly designed and installed. A properly grounded and bonded system is essential for safety and to prevent electrical shock hazards. Seventhly, consider the use of energy management systems to monitor and control the energy consumption of the strip mall. Energy management systems can help to optimize energy usage and reduce overall operating costs. Eighthly, coordinate the electrical design with other building systems such as HVAC, plumbing, and fire protection to ensure that all systems work together harmoniously. Ninthly, perform a voltage drop calculation to ensure that the voltage at the furthest point in the electrical system is within acceptable limits. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Tenthly, document all of the calculations, assumptions, and design decisions made during the electrical service sizing process. This documentation will be helpful for future maintenance and upgrades. For calculating the demand load accurately, start by determining the connected load for each unit. This involves summing up the power requirements of all the electrical equipment that is expected to be used in the unit. Secondly, consider the diversity of loads within each unit. Not all equipment will be operating simultaneously, so applying a diversity factor can reduce the calculated load. Thirdly, determine the non-coincident demand for each unit. This is the maximum demand that is likely to occur at any one time, taking into account the diversity of loads. Fourthly, apply a demand factor to the non-coincident demand for each unit. This factor accounts for the fact that not all units will be operating at their maximum demand simultaneously. Fifthly, sum up the demand loads for all the units to obtain the total demand load for the strip mall. Sixthly, add the load of the landlord panel to the total demand load. Seventhly, consider any future expansion plans and add capacity to the electrical service to accommodate these plans. Eighthly, consult with the local utility company to determine the available fault current at the service entrance. This information is needed to properly size the overcurrent protection devices. Ninthly, ensure that the electrical service is designed to meet all applicable codes and regulations. Tenthly, document all of the calculations and assumptions made during the load calculation process. When reviewing NEC requirements, pay close attention to the requirements for service entrance conductors. The service entrance conductors must be sized to carry the calculated load. Secondly, ensure that the grounding electrode system is properly installed and meets the requirements of the NEC. Thirdly, review the requirements for overcurrent protection of the service entrance conductors. Fourthly, consider the requirements for surge protection devices. Surge protection devices can protect sensitive electronic equipment from damage caused by voltage surges. Fifthly, ensure that the electrical service is properly labeled and identified. Sixthly, review the requirements for working space around electrical equipment. Adequate working space is essential for safety and to allow for maintenance and repairs. Seventhly, consider the requirements for accessibility of electrical equipment. Electrical equipment must be accessible for inspection and maintenance. Eighthly, review the requirements for conductor ampacity. The conductors must be sized to carry the calculated load without overheating. Ninthly, consider the requirements for voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Tenthly, ensure that all electrical work is performed by qualified and licensed electricians. When consulting with the local authority, be prepared to provide detailed information about the project, including the load calculations, electrical drawings, and equipment specifications. Secondly, ask the local authority about any specific requirements or interpretations of the NEC that are applicable to the project. Thirdly, inquire about the permitting process and the required inspections. Fourthly, obtain any necessary approvals from the local authority before starting any electrical work. Fifthly, maintain open communication with the local authority throughout the project. Sixthly, be responsive to any questions or concerns raised by the local authority. Seventhly, address any code violations or deficiencies promptly and effectively. Eighthly, ensure that all electrical work is performed in accordance with the approved plans and specifications. Ninthly, cooperate with the local authority during inspections. Tenthly, document all communication with the local authority. When considering voltage options, analyze the anticipated load requirements of the tenant. Higher voltage systems, such as 480 volts, are generally more efficient for large power loads. Secondly, consider the availability and cost of electrical equipment for different voltage levels. Thirdly, consult with the local utility company to determine the available voltage options and the associated costs. Fourthly, evaluate the voltage drop for different voltage levels. Higher voltage systems generally have lower voltage drop. Fifthly, consider the safety implications of different voltage levels. Higher voltage systems require more stringent safety precautions. Sixthly, determine the most cost-effective voltage option, taking into account all of the factors mentioned above. Seventhly, consider the potential for future expansion and choose a voltage level that can accommodate future growth. Eighthly, consult with a qualified electrical engineer to determine the optimal voltage level for the strip mall. Ninthly, ensure that the chosen voltage level meets all applicable codes and regulations. Tenthly, document the decision-making process for selecting the voltage level. Regarding panel coordination, perform a short circuit study to determine the available fault current at each panel. Secondly, select overcurrent protection devices that have adequate interrupting ratings for the available fault current. Thirdly, coordinate the overcurrent protection devices to ensure that the device closest to the fault will trip first, minimizing the extent of the outage. Fourthly, use time current curves to verify that the overcurrent protection devices are properly coordinated. Fifthly, consider the use of selective coordination, which ensures that only the faulted circuit is de-energized, while the rest of the system remains operational. Sixthly, document the coordination study and the settings of the overcurrent protection devices. Seventhly, test the overcurrent protection devices periodically to ensure that they are functioning properly. Eighthly, provide training to maintenance personnel on the proper operation and maintenance of the overcurrent protection devices. Ninthly, review the coordination study whenever changes are made to the electrical system. Tenthly, consult with a qualified electrical engineer to perform the panel coordination study. Concerning load balancing, distribute the loads evenly across the phases of the electrical system. An unbalanced load can cause voltage imbalances and overheating of conductors. Secondly, use a load balancing software program to optimize the load distribution. Thirdly, monitor the current on each phase to identify any imbalances. Fourthly, adjust the loads as needed to achieve a balanced load distribution. Fifthly, consider the use of single-phase and three-phase loads to balance the load across the phases. Sixthly, provide separate circuits for high current loads such as motors and HVAC equipment. Seventhly, use a common neutral conductor for multiple circuits to reduce the neutral current. Eighthly, ensure that the neutral conductor is properly sized to carry the maximum unbalanced load. Ninthly, consider the use of automatic load transfer switches to balance the load during peak demand periods. Tenthly, document the load balancing plan and the measures taken to achieve a balanced load distribution. When conducting a load study, start by gathering historical data on the power consumption of similar businesses in the area. Secondly, use metering equipment to measure the actual power consumption of the units over a period of time. Thirdly, interview the tenants to understand their power usage patterns. Fourthly, analyze the data to identify peak demand periods and patterns. Fifthly, develop a load profile for each unit based on the data collected. Sixthly, use the load profiles to calculate the total demand load for the strip mall. Seventhly, compare the calculated demand load with the actual power consumption to validate the results. Eighthly, adjust the load calculations as needed to reflect the actual power consumption patterns. Ninthly, document the load study methodology and the data collected. Tenthly, update the load study periodically to reflect changes in occupancy or power usage patterns.